are where prism
Hey
or the
guys,
polyhedron,
today we're talking about line segments
whatever
and the
it
distance
is,
formula.
the polygon, the prism, the pyramid,
so what
whatever.
Is a line segment?
It's the polyhedron. It goes straight through and cuts diagonally,
points,
hence the word
and
diagonal,
in this case, it's on a
through
graph.
to the
so
other
if
vertex.
They give us two ordered pairs, and they
there are
want us
also
to find
solids
the
that are
length of
not
the line
polyhedrons.
segment,
For example, a
we can use the
cylinder and a
Pythagorean
cone.
theorem
Again, you might want to either
along
print these
with,
notes out or sketch them yourself.
The coordinate
A
points
cylinder
to figure out the distance.
are those a cone.
So
think of an ice cream cone. If it was flipped over, you could store your ice cream in it. These are kind of similar to our polygons.
The distance that these 2 points
while
make.
the cone only has one face,
that if
similar to a pyramid,
in these,
or
here,
one
these
base,
line segments, it would form that right triangle.
When we look at them, though,
so in this
do you
case,
notice that that's all they have? They only
one
have those two faces that we
5,
also call bases, and they don't have any other straight, flat sides.
This one, our C, we don't know. So
okay, so how do we identify them?
We can take
a prism
squared
has at least three lateral faces that are parallelograms. Okay, so rectangles, parallelograms. Okay.
So we get 25
squares or
plus
parallelograms.
16 equaling our
the top
C
and the bottom
squared.
faces are called. So again,
We get 41,
there's a lot of vocab
and then
here.
We need to
I need you to either
square
print them
to
out
find C,
or make sure
and
that
we
you
get
have them written in your notebook. Okay. So make sure you
6.403,
utilize that
going.
print
So
feature
if we rounded
that I
this,
have on
it
Blend
would just
Space.
Be 6.
Identifying cones and cylinders. A cone has only one base. Okay, while the cylinder has two. Remember we talked about them, and they're both circles.
There's another way that we can
cone
do this
only has
without
one
having to
vertex.
graph.
These have no vertices,
formula.
no edges.
Please write this down.
Edges have to be those flat pieces,
distance formula
and the vertices have to come to a point, and they don't do that. Same thing with the cylinder or with the sphere. He has no faces, bases, edges, or vertices. His only distinction is that he's got that spherical shape, and every single point that we put on this spherical shape would be exactly the same distance from that center point.
That was a comma.
Okay, basketballs.
You're going to take
those
your
are
x2 and
spheres.
subtract your x1 and then square it. And then take
All
your
right,
y2
so take a
and
second,
subtract
pause
your
the
y1
video, and try these. I'll be back in. Cube has two square faces or bases, and remember, all of them could be considered the base because they're all squares.
Plug them in
and then we've got a pentagonal
D equals
pyramid.
The square root of, and my x2
I got
is 7
interrupted. So I think I said
3,
pentagonal
and
pyramid
I'm
has a
square
pentagon
that.
as its base.
And then I'm going to add
there's
to
only
that
one, so
my
that's why it's a
y2,
pyramid.
which is
While the octagonal
-5
prism
minus
has
0, and
two
I'm going to
bases
square
that are both octagons.
So we get
okay, so
4
cross
squared
sections
plus
are intersections of a
-5
solid and a
squared.
plane, and it's
So
called
as
the
you
cross
know,
section. Okay,
if we
so when
square
I take
positive
this
or negative
plane,
number, they come out positive. So
like
we
think
get
of a plane as being
16
like
and 25.
a little sheet of paper or
And
something,
when we
and it slices through
square root of
the
that, we
prism
get
or the
41,
pyramid or dotted
and
line.
41
A triangle.
41.
So the
square root of
cross section
41
is a triangle.
6.4.
When I
Sorry,
slice
that was so
it
hard
like
for me to get
this
out.
horizontally,
And we're going to say the same
I
thing
see
like we
a
did in the last
square.
one, units.
Okay,
So if we compare these
the
two,
horizontal slice
notice
of a
that they
square
are the
pyramid is a
exact
square,
same.
and the cross section of a
Graph this
vertical
one for me,
on
and
the
then go
square
ahead
pyramid
and
would be a triangle.
use the distance formula, and I'll be back in
All
just
right,
a second
so try
to show
this
you what
one.
I
Name
did,
the shape
okay?
and describe the
You're
shape
using
resulting
the
from the
graph
vertical or horizontal
and the distance
section
formula.
of the cylinder.
All right, so
Okay,
the first
if I
point
slice
that we
this
need
one,
to do
he
is
is
plot them.
so I'm just going to go
So if we
through. I'm
look
not going to
here,
write
this
each one
line
of them
segment is a
and tell
1,
you what
this
each
is a
one would
3,
be.
and we
You
don't know our
slice
C.
this
So 1 squared
or vertically,
plus 3
you would see
squared,
the triangle, and
which
if you
equals
slice
1
it
and 9.
horizontally, you would
Add them
see a
together, we
rectangle.
get 10.
If you slice
And
this
then
one
to find
vertically,
C,
you would see up
we
and down. You would see a
have to
triangle,
take the
and
square root of
horizontally,
10.
you would see a triangle.
So we get 3.2 when we round because the 6 tells the 1 to become a 2. Now let's look at it with the distance formula. If we
Let's
plug
work
in the
with
numbers,
cones today, finding their
the
volume.
-2 minus
the volume
1
of a cone with a
squared,
radius
and
is
then
1/3 the
4
area
minus
of its
3
base,
squared.
or b
Here
times
we get
the height,
negative
h.
3 squared,
So if we're
which is
looking,
9,
this is the formula that we use.
4 minus 3
1/3
is
the
1,
big base
and if we square
times
it,
the
we
height.
get
Or instead of thinking
1.
of it as the big base,
So
we think of it as pi
when
r
we
squared because
take
the base
square
is
root
a
of this,
circle,
notice that
and
this
the
is
area of a
same
circle
thing
is
that we
pi r
just
squared.
did. We take the square root of 10.
So this is the formula that I would suggest having in your notebook.
3.16227.
So a cone is a three-dimensional figure with one circular base connected by a curved surface to a single vertex.
Is about
so to find this cone's volume, we need to make sure that we round to the nearest tenth, because that's what they asked us.